Hey everyone, I wanted to talk to you today about using inversions to name intervals. This is going to make naming intervals so much easier for you. Let me start by drawing a picture of our major scale in the way that we built it. You may recall that we built our major scale using two whole half tetrachords separated by a whole step, so that the intervals in our major scale are whole half, whole half. Now you can see that I've written in the scale degree numbers, and I've put the little caret above each one of them that shows that it's a scale degree. And in fact, I'm going to add one more thing to make it even clearer. There you go. Since we're dealing with a major scale, the first scale degree is do, the second scale degree is re, the third scale degree is mi, and so forth. Fa, sol, la, ti, do. Therefore, you can also see immediately that if you go from do to re, you have a whole step, which is going to be, because you have two adjacent letter names or two adjacent solfege names, it's going to be a major second. Re to mi, also a major second. Mi to fa is a half step, and so that's going to be a minor second. Fa to so is a whole step, therefore a major second. So to la, major second. La to ti, major second. Ti to do, minor second, because it's a half step. So in a major scale, in fact in any diatonic scale, you only have two half steps. And in a major scale, those are going to be between mi and fa and ti and do. That means that if we were, only to add another color here, if we were to add letter names to this, say for the C major scale, C, D, E, F, G, A, B, C, that our half steps are between E and F and between B and C. That's good to remember when we're going to use natural intervals to help us identify these as well. But here's the quick thing I wanted to show you. So we have a way of looking at intervals, which means you only have to learn half as many. Okay? Let's talk about what the inversion of an interval is. So the inversion of an interval is the interval that you add to it to get to an octave. So if we have do to re, which is a major second, then re up to do is going to be a minor seventh. Okay? So the inversion of a major second is a minor seventh. In fact, the inversion of any major interval is always going to be a minor interval. And the two numbers of those intervals, because of the way we calculate them, will always add up to 9. 2 plus 7 equals 9. I know you thought you were done with math, but you're not. Okay? So, as we do inversions, just remember that the numbers are going to add up to 9. And that major intervals will always become minor, the inversion of a major interval will always be a minor interval. So when we have C up to E, that's a major third. Major third. So what does that mean E up to C is going to be? That will be a minor sixth. 3 plus 6 equals 9. So the numbers add up to 9, and the inversion of a major interval will be a minor interval. All right, let me erase that again. And let's take a look. Oh, so now we get to a special case. So we have C up to F. That is a perfect fourth. C up to F is a perfect fourth. What is the inversion of that going to be? Well, we have, now we're going to do algebra. 4 plus what equals 9? The answer is 5. So the inversion of a perfect fourth is going to be a fifth. And what kind of fifth is it going to be? The answer is perfect. The inversion of a perfect interval is always going to be another perfect interval. All right. The thing is that we can continue this, but it's just going to continue to be the same thing. We've covered most of what we wanted to talk about. But let me just get past this a little bit. So obviously a perfect fifth from C to G, the inversion, G up to C will be a perfect fourth. But let's also look at, I'm going to go C up to A. Well, that's a major sixth. Major sixth. So what is A up to C going to be? A minor third, because 6 plus 3 equals 9. And the inversion of a major interval will be a minor interval. And let us just do one more so that we can see how things go within the octave. Then we will have covered just about every instance. We'll have one more to talk about. So C up to B is a major seventh. This is kind of doing it backwards from the thing I wanted to show you, but that means B up to C is going to be a minor second. So a minor second is the inversion of a major seventh. 7 plus 2 equals 9, and the inversion of a minor interval will be major. Okay? This is so super useful. What's the one interval we haven't talked about that has an inversion? Let's talk about it in this way. So I'm going to put right here F sharp. F sharp. So if C up to F is a perfect fourth, what is C up to F sharp? Well, if we take that perfect fourth and we add a half step to it, and we expand, we raise the upper note by a half step, we will get an augmented fourth. A for augmented, an augmented fourth. What is the inversion of an augmented fourth? Which we also call a tritone. The inversion of that tritone is going to be what we often colloquially call a tritone as well, but this is actually going to be a diminished fifth. Remember, to calculate the generic interval, we have to count the letter names. And if we count the letter names, F, G, A, B, C, we get 1, 2, 3, 4, 5. So it's got to be a fifth. And you see that we raised the bottom note by a half step. And therefore, instead of being a perfect fifth, it becomes a diminished fifth. Okay? So a perfect interval enlarged by a half step becomes an augmented interval, and a perfect interval made smaller by a half step, but with the same letter names, gives you a diminished interval. Mostly we're not going to worry about that, but if you do see a tritone, then if you see C up to F sharp, that augmented fourth, when inverted, becomes a diminished fifth. Okay, so let's look at how to use that in practice. So I've got some standard notation here to show you, but really the thing that I wanted to most show you was that if you have a second, the inversion of that will be a seventh, and if it was major, it will become minor in its inversion. And if it's minor, it will become major in its inversion. So a second will become a seventh, and a seventh will become a second. But, and thirds, when inverted, will become sixths. Same game. Major will become minor, minor will become major. And last but not least, fourths will become fifths. And they are both perfect. So as long as they're perfect, they stay perfect. That means that if you can identify seconds, thirds, and fourths, you will also be able to identify fifths, sixths, and sevenths just by seeing what inversion they are. So let's talk about a few things that will help you identify them specifically when you see them. One thing to remember is another pattern. Well, let's start off with seconds. So, one thing to remember is if we're looking at natural intervals, the interval between, that looks like a smiley face, but the interval between C and D is a major second, okay? And in fact, all the intervals between each pair of adjacent notes are major seconds except for what? Well, from E to F, when we're talking about natural intervals, that is a half step. I love that these are all smiley faces. And therefore, it's going to be a minor second. Okay, F to G is a major second, G to A is a major second, A to B is still a major second, and B to C, that is our other half step in our major scale, in our natural interval, and that is going to be a minor second as well. So you just have 2 minor seconds to watch out for in terms of natural intervals, intervals with no accidentals, and that is between E and F and between B and C. Those are your 2 minor seconds to watch out for. Everything else is a major second. Okay, so that means that when we have an interval like, when we have an interval like D up to C, you can go, wow, that's a big interval. I'm not sure what it is, but instead what you'll think is, well, C up to D would be a major second. So D up to C is going to be, the second becomes a 7th in inversion, so we know it's a 7th. We could see that anyway. And then because we knew it was a major second, we know that that is a minor 7th. It would be great to know that without having to figure it out, but that is a really easy, quick step to figure it out if you're having trouble. Okay? Similarly, E up to D, again, that's going to be a minor 7th. How about F up to E? F up to E, you know E up to F is a minor second, so that's going to be a major 7th. F up to E is a major 7th. Okay, so that's one way that you can utilize that. So let's talk about thirds, because thirds are going to be the next most common thing that you're going to need to worry about. There is a great pattern here that you should remember for other reasons as well. Okay, so first of all, we have C up to E, which is a major third. And then before we talk about inversions, let me just show you this pattern because it's a pattern that you're going to need to remember for other reasons. So here is D up to F, and that is a minor third. Remember, major, minor. E up to G is again a minor third. F up to A is a major third. G up to B is a major third. A up to C is a minor third. And this one is an outlier a little bit in the pattern, but we're going to just remember that B up to D is also a minor third. This is going to become a very familiar pattern to you as we do triads, because when we write the triads for these, they're going to have those same qualities, except for that one that I told you was an exception. So let me do it in red here. The chord that begins on C in C major we'll do with a capital 1 for a 1 chord. When we do a 2 chord, it's going to be minor in a major key because of that minor third. When we have a 3 chord, it's also going to be minor because of that minor third on the 3rd scale degree of a major scale. When we get to the 4th scale degree, the triad built on that will be a major chord. And same thing with the 5th scale degree. The 6th scale degree will be minor. And the trick here is that the triad built on the 7th scale degree is going to be what we call a diminished triad. I don't want you to worry about that till we get to triads, but just know that that is a triad with two minor thirds stacked above each other. So remembering this pattern is something you're going to need to know in the future anyway. So just remember major, minor, minor, major, major, minor, and for now we'll just say minor because we're just looking at the thirds. So then that means if you can remember where you are in the scale, and since we're going to just look at natural intervals first, then you can also quickly identify sixths because they will be an inversion of those intervals. So the sixth from E up to C, wow, let's do that. Sixth from E up to C is going to be a minor sixth. And the sixth from F up to D, well, D up to F is a minor third, so we know that's going to be a major sixth. Does that make sense? So there's no point in me writing them all out for you. You can figure it out according to those rules. But it's this pattern that's going to be very useful. Major, minor, minor, major, major, minor, and minor for the beginning third of that last chord. And then you will need to know that for triads as well, so just learn it as a pattern. That should make it easy to identify, therefore, seconds and thirds and sevenths and sixths. Then, with fourths, there is a great trick. First of all, you know that a perfect fourth inverted is a perfect fifth. So the only thing you have to watch out for, there is only one interval in the diatonic scale that is looks like a fourth and is not a perfect fourth. And it is B, oh sorry, I did it the wrong way. It's F up to B. F, G, A, B. That is 3 whole steps, and 3 whole steps makes a tritone. That's why it's called a tritone, because it's 3 whole steps. So unless the 2 notes are F and B, you know that any fourth you see is perfect, as long as we're talking about natural intervals. If the 2 notes are F and B and they are a fourth apart, then they are an augmented fourth. And if the 2 notes are F and B and they are a fifth apart, like these two, there you go, B up to F, then that is a diminished fifth. As long as you can identify quickly and correctly seconds, thirds, and fourths, then you can quickly identify correctly sixths, sevenths, and fifths. Sorry, I said that in the wrong order. As long as you can see what their equivalent inversion is in the second, third, and fourth. And just remember, minor or major becomes minor when you invert it. Minor becomes major when you invert it. Perfect remains perfect when you invert it. It's perhaps not necessary to say, but augmented becomes diminished when you invert it, and diminished becomes augmented when you invert it. So I'm going to do another video for you about how to deal with intervals that are not natural intervals, that have accidentals on them, but the one thing to do is to quickly identify natural intervals, because then it is trivial to then also see what they become when you enlarge them or diminish them, when you augment them or when you diminish them. All right, I'll see you soon in another video.